Congratulations, Cat. You have been selected to pilot a spaceship alone in search of supplies for your colony. This will be a dangerous task, but your friends wish you much needed luck. We hope you are able to return home one day.
NASA wishes to be on the moon again by 2024. SpaceX has its eyes on Mars for 2026. Russia wants to launch its own space station into orbit by 2030. Our desire to explore the outer reaches has only grown since the first moon landing, but actually getting into space is difficult, and many space programs have limited resources. So how will we get there? You've probably heard the words artificial intelligence, or AI for short. It's a field of computer science usually associated with androids or hyper-intelligent computers. But AI is really used everywhere. This technology takes advantage of statistics, calculus, probability, and linear algebra to create machines that assist and perform tasks that only we organic creatures could before. Let's look back at Cat as an example.
The resources that Cat needs are only on one of the 234 planets in her solar system. However, she has no idea which one, and she only has a limited amount of fuel and time. Cat has to know which planet has the resources she needs before she gets to it, and she has to do this quickly.
So she needs AI to assist her. Cat plans to harness the power of this technology by building a predictive neural network. As the name suggests, neural networks are meant to loosely mimic our own neurons. For Cat's program, it needs to take information from satellites and telescopes that monitor the planets to produce an output that tells Cat what's on it without her actually being there. Here is the input layer. For Cat's program, the input layer might represent things that signal the presence of what she's looking for. These lines that connect the circles are known as weights. A weight represents the relationship between a value and an output. A smaller weight has little effect, whereas a higher weight can have a substantial impact. For the network to keep propagating forward, the inputs need to be multiplied with their weights. Remember, computers think in numbers, so by doing this, the program will gain a better understanding of the input. After being multiplied, it is sent to the secret sauce hidden layer. Each of these has a number called a bias. The bias is added to the dot product sum, which is sent through to the activation function. If activated, it continues along transmitting the data to the next layer, and the circle with the highest value determines the output. But wait a minute, Cat's program is wrong. Well, that's because the weights and biases we saw were just randomized. Don't worry, this is a key part of the network's training. To improve the model, Cat needs to figure out how wrong it was by calculating its loss function. The program has to figure out how far off it was and adjust as needed through gradient descent, which improves the weights little by little. Cat's program will repeat the training cycle until it is accurate and efficient enough that Cat trusts it to make calls by itself. And soon, her program is confidently analyzing new data,
And it soon finds the ideal planet.
what would have taken Cat days was completed in record speed. She double checks like any good scientist, and sure enough, Planet 103 is the answer to her problems.
Cat arrives, collects what she needs, and returns home a hero.
Of course, Cat is a fictional alien, and the example given is a little simplified. However, actual scientists use AI all the time in space exploration. What Cat used is definitely not the only example. Chatbots like NASA's helpful bot Astrobee use natural language processing. Or how about the AI that was used to design the perfect Mars house? By using AI, space programs can free up resources, like people, money, and materials, to work on other mission jobs, creating a faster, more efficient environment.